So basically, the graph are pictures of distributions, and one of the graphs that you can construct is the histogram. So the histogram is a bar graph in which the horizontal scale represents classes of data values and the vertical scale represents the frequencies. The height of the bars correspond to the frequency values, and the bars are drawn adjacent to each other, so there is no space between the bars, right? That's why to construct my histogram, I will use my class boundaries, because remember that if we use lower class limits and upper class limits, we will have a gap of 1 unit. So we will have a gap in the histogram. And we don't want to have a gap in the histogram, so I will use the class boundaries instead of the class limits, right? So my first class for my histogram will go from 0.5 to 99.5 with a frequency of 11. So the y-axis is the axis of the frequency, the x-axis is the axis of the classes. So my first class go from negative 0.5 to 99.5, because I have the class boundaries. The second one goes from 99.5 to 199.5, from 199.5 to 299.5, 299.5 to 399.5, and from 399.5 to 499.5. Then the frequency of each is just the frequency that you have here. So, for example, for the first class, the height of the first bar is 11. The height of the second bar is going to be 12. The height of the third bar is going to be 14. The height of the fourth bar is going to be 1. The height of the second bar, or the fifth bar, sorry, is going to be 2. So this is a histogram. So remember, in the histogram, you have no gaps, right, between the bars. And each bar, the height of each bar represents the frequencies. Exactly as we have, histograms constructed with a frequency distribution, we can construct the histogram using the relative frequency. And we're going to call that histogram a relative frequency histogram. Again, we're going to use the class boundaries. You remember that we calculate in a previous table the relative frequency of each of the classes that we're using in this example. So just get, and in this case, instead of using the actual frequency in the y-axis, instead of using the actual frequency in the y-axis, using the relative frequency, so in percentage. So you have the first bar have a height of 28%, the second bar have a height of 8%, the next have a height of 35%, the next 3%, the next 5%, and so on. Right? So this is basically a relative frequency histogram, have exactly the same shape and the same horizontal scale as the histogram that I showed you before. So if you look at two histograms, both have the same shape. The horizontal scale is the same, but the vertical scale is with relative frequencies instead of the actual frequencies. And then we can do a frequency polygon. And a frequency polygon uses line segments connected to points located above the class midpoint values. So how do you get a frequency polygon like this? Well, you will mark at the class midpoint point here in the middle of this class, at the top of the bar, the position of the class midpoint. Remember that for the first class, we said the class midpoint is 49.5. So 49.5, we will mark, a point 149.5, you will mark a point, and like that, you will mark a point. Here, you will locate a point here in the middle of each bar, at the top of the bar, right, where the midpoint of the class is, and then you will later join with segments all those midpoints. Important to highlight that in a frequency polygon, in a frequency polygon, you always start in 0 and you always end in 0. So the frequency polygon is closed.